All right. We are here with John Magradey, my high school
Hello.
friend who is now living in Glasgow, Scotland, and he's willing to share with us about some of his engineering experience, thankfully, despite the time difference. And I've been really excited to learn from John's experience because some of these are stories that I haven't heard yet. John, would you be willing to share a little bit about how you came to be an engineer and then
Okay.
now a software engineer developing some of these new skills? When did you first get interested in this career? And then what have your sort of learning experiences been like along the way?
For sure. I think I got interested in this career when we were still hanging out in high school, doing all those math classes. I've always been kind of math minded and solving challenges. Uh, Engineering school felt like the right thing for me, and it's what I was good at. I also had a parent who was a tap dancer and was pushing me away from the arts, so that certainly helped as well. But follow your dreams.
Engineering is an art, in my opinion,
It
but
is, and certain aspects of engineering I think are the closest thing we get to magic. So
yes.
there's that as well. Yeah, in college I got a degree in materials science and engineering. Pretty quickly didn't follow that path at all and went into aerospace because rockets and planes and stuff are really cool.
Aerospace needs material science stuff.
They do, yeah. They do desperately. And that's how I, got into the field. I just found more and more that as I worked on different materials projects. I went to grad school for material science as well, and everything kind of revolved around some. I was more practical engineer, practical science in that, where like a experimentalist. So I did a lot of microscopy in my grad school, and everything was revolving around data collection and then writing your own software to utilize that data and moving forward with that software development. And it came, my favorite part of my job was like figuring out how to write the software to collect and display the data that I got from my material science experiments. So that's what got me really interested into the software side of things and
And this is
started to make that
before
pivot.
you've been in the industry at all? Was
Yeah,
this
yeah, even before I found myself drawn more to some of the software side of things from my
so
experiments.
you went into college at Clemson and you settled on materials science and engineering your freshman year and stuck with that the whole time, or
Yeah, yeah, which is kind of wild that we're told to choose your career right away. Again,
yeah.
I'm living proof that that doesn't have to be the case, especially in the field of engineering.
What were the classes like for that? Were they engaging? Did you feel like you learned useful stuff in hindsight, or like what do you remember about your classes?
I don't think so. I mean, there's a lot of general engineering classes that focus on some programming and higher maths, but the most important thing with college and also just all education is, learning how to learn
Yeah.
stuff and doing so at a high pace.
Hmm.
It's kind of the most effective thing that I think comes out of my degree is just looking at a problem and going, I can figure this out because I spent so many years figuring out things that I had no idea how to do before.
Hmm. So I think if you mention like learning to learn to a student these days, they might think, oh, learning to like hack the test, how to look at multiple choice questions and see what can't be D. They're probably trying to trick me with C, so the answer is probably B. Or like, oh, if I just cram 3 hours the night before, or I do last year's test. But like learning to learn in the real world means you're kind of faced with a problem that you don't necessarily know how to solve. And then you're like, okay, I got to
Hmm.
figure this out. And the internet plays a big role, and trial and error plays a big role. Learning how to frame the problem correctly probably plays a big role. Experience, communicating with people who might be able to help. Like, which of those stick the most for what your experience has been like?
Man, six of one, half a dozen of the other.
Yeah.
It's a mixture of all of it, and also having the confidence to know you can tackle a problem like that.
Yes. Yes. Which maybe comes
Learning
from
all
a
the
long
skills.
time of like ripping your hair out of like, how do I figure out this problem? And
Yeah,
then
yeah.
finally
And
it
not
happens.
to discount the cramming throughout for a test and learning which answer might be right. I know as a teacher, that's probably not the best thing you want to hear, but
No, I mean,
that's
as a
valuable
teacher,
skills too.
it's on us to like come up with better challenges and exams that we put our kids through.
Yeah. It's an arms race.
Yeah. It shouldn't be like this like hack thing. If you find
Mhm.
the hack, that's nice and clever, but we've got to be better world builders.
Yeah.
Anyways, so and then you went immediately into your master's after finishing that?
Yeah, I finished undergrad. Actually went straight into a PhD, but quit that after a few years.
Did you
And
finish the master's portion of it?
I did, yeah.
Okay.
So I left with a master's, and I left for a variety of reasons. One was I wasn't super interested in the thing I was studying for a PhD. So
What was it?
it was magnetic thin film interactions, specifically looking at like using really high powered microscopes to look at the interficial layer between atoms
Hmm.
and two metallic thin films. I honestly can't speak too much toward it because, as I said, I wasn't good at it and I wasn't very
Hmm.
interested in it. And so PhDs are that special thing where you really have to be interested in the subject you're pursuing.
Yeah.
It's a passion project, not a.
Take me back to like junior, senior year of undergrad. Like, how did you decide that was the path you wanted to do before knowing what the project might be like?
Mainly, I just wasn't done learning. I think in hindsight, I still am not done learning a decade later, which you can learn in all capacities and all different times in your workplace, out of your workplace. Maybe I would have made a different choice, but at the time, I still felt like school was the vehicle to achieve that extra learning I need. I just wanted, I thirsted for more
Yeah, yeah.
knowledge.
And if you take time away from school, you kind of feel like you might get rusty or something. So you just might as
Yeah.
well not fill out. Um,
Mhm.
but so you were like, you loved the learning process through all of college. Like you're not skipping classes. You're excited about lectures, reading the textbook. What was that like?
Oh, I mean, I skipped classes and got bad grades at times.
I'm
I
gonna
think
edit that part out.
uh, I think it changed over time. I learned to love it
By the end,
as
yeah.
yeah. It definitely had a different perspective on school exiting college than I did entering it, and also leaving high school. It became such a special part of my life, and my now wife was also a big part in that. We connected a lot through uh the school, and I started college thinking it was cool to maybe wait last minute, and then I found out I could impress her more by doing my homework early and getting good grades.
What point did y'all start dating?
The junior year of college,
Yeah.
so I was on the upswing.
Coincidentally, it's seeming like the time that this change might have occurred.
Yeah, much
Yeah.
to the happiness of my
Thank
parents.
goodness that these positive influences land in our lives.
Yeah, yeah. We actually took a astrophysics class together when we first started dating,
Wow.
just for
Definitely
funsies.
some studying required there. So you did the master's in basically the same discipline as undergrad. When did you have to pick this, or was the thin film project foisted upon you? That's not a word, but thrust upon
Uh,
you, or
a bit. Um, I had an advisor, and then that was his major projects that was funding attached to it. So I was
were
just
you
working
attached
on
to
his
this
bit.
advisor from the very start of your grad school program? Did you get
No,
to
it's
when like when did
you
they
kind of get to
voice it?
choose. I entered just as kind of a general PhD candidate. And then there was a couple of others doing various different projects, and you kind of walked around, talked to them, interviewed because they have to choose you as well as you choosing them. And it seemed like a right fit. I got excited about the project from the get-go. It just wasn't for me, and
Eventually,
here
when
I
you got
am.
into the grind of it, you were sort of like, was it was it just like the daily grind was not enjoyable, or was it that you actually like just fell out of love with the subject? Was
A
it like
bit
I
of
don't see how this
the
is going to be important, or what?
no, it was. It seemed I could see the applications, and the science was cool. I wasn't passionate about it in that way. I wasn't like, I want to dedicate the next 5 years of my life to only this thing. I think one of the tough things about engineering early on is feeling like you have to choose, but there's so much out there. You really don't have to narrow in. You can absolutely focus in on a subject, but that's just not how I like my engineering career to go. I like knowing a lot about a lot of things, and
Yeah,
there's value in that.
yeah, super cool. And so in the master's part of it, there was a lab element, and that's when you were collecting all this data.
Hmm.
And that's when you started to get the taste of software engineering or programming and started to fall in love with that. Is that
Yeah,
right?
yeah, that's
And
exactly right.
what specifically was it about it? The nature of the problem solving or
A bit, yeah. To me, the software engineering side of it, everything you do is a little tiny piece of problem solving. You're saying like, how do I do this? How do I do this? And it's even like writing something to capture the file in a way that you want it to. It's a little tiny problem that you have to solve.
Mhm.
And just like when it works and you get that little dopamine hit from a code that compiles, even if it's
Yes.
the most mundane task, I live
Yeah.
for that.
Those rewards are super important, like to have
Yeah.
like little nuggets that keep you going.
Hmm.
The that's a really interesting point. Okay, so you made the switch to industry to leave the PhD. You still think PhD could be a good thing for a lot of students, but you really have to have a lot of
For sure.
passion for the subject and
Mhm.
be sober minded that it's going to be a really long time with just one very niche thing. And so what was that process like? Finding a job, looking for a specific job, what
Cool.
was going on in that season?
I think the search for your first job is one of the most stressful period of an engineer's life. Some people get pretty lucky coming out of an internship and going straight into a job that'll hire them right away. But I don't know, it's such a common, even the brightest people I know, it's the first job. It feels like you're never going to get it and you're not going to get the right one.
Yeah.
Uh, but I am, maybe your students aren't far away from this point in life, but I'm here from the future to tell them that everyone gets a job.
It'll all work out.
Yeah. Yeah,
Trust
it's
God.
it's like if you stick with it, like people get employed. There's split swings right there. But yeah, that the process was super stressful, but I ended up at Boeing for my first job and it was a really great fit, even from the get-go.
Nice. How long was that process? Was the interviewing crazy, stressful, or what was the process like? Did you apply to a bunch of
Months
jobs?
long, applied to hundreds of jobs. Didn't hear back from a ton, and then I eventually, when it rains it pours. I got a few offers after getting tons of rejections.
Yeah. When it rains, it pours. Yeah, that's well said.
Yeah.
And what was the title on this job, and where were you located?
This was over in Seattle,
Okay.
and it was a non-destructive evaluation engineer for their research and development group,
And so,
and
for
that
those who are
was
unfamiliar, what is like non-destructive evaluation, and how does it fit into?
non-destructive evaluation is essentially like in its basis form, can you diagnose the health of an object without tearing it apart? Which
And
on airplanes,
what does
that's
the health
really
mean,
important.
like of an airplane wing? What does it mean for an airplane wing to be healthy?
So very few or little cracks or known defects. So if you taking a metal airplane wing and it has a bunch of rivets in it, what they do with a lot of those, and the reason we can fly airplanes so frequently they just like never turn off and they last for decades is because we know exactly how cracks form in metal at those junctions, at the weakest parts of the aircraft. We've done studies through non-destructive evaluation and also active monitoring of current aircraft where we take these methods, we inspect the wing of the plane, and we say, hey, we know we're confident through previous engineering practices and documentation that this airplane wing is a healthy airplane wing and doesn't have anything going wrong in it and it can keep flying.
How frequently is like a standard wing evaluated physically for cracks?
Every aircraft has its own specifications and also depends on if there's been issues in the past. So there's certain areas that get monitored quite regularly after every few cycles, like a few thousand cycles. Like every time when you cycle an airplane, it's when you take it to altitude and you land. So you pressurize the cabin, you fly it, and then you land. And there's different areas of the plane all over that have different inspection cycles, and
Yeah, that's
you look
helpful in
for.
terms of identifying like cycles because I was thinking about like just specifically a crack like opening and closing cycles. But if you're like on a wing, the wing could be like fluttering the whole flight and see hundreds of thousands of cycles. But
It's hard to
so
quantify. Yeah.
yeah, fatigue. I'm really trying to learn a lot about fracture mechanics myself right now because I want to incorporate some of that stuff into my class. and I don't think we're going to be able to do much like non-destructive evaluation, but the analysis piece of it, or just conceptual understanding of like how maybe crack formation, propagation, and dissipating energy when cracks are growing can play a bigger
Mhm.
role than just like a traditional stress type analysis.
Yeah. It's a super cool science. It's pretty fun to watch how things fatigue and then how like not to scare people like flying is super safe, but planes have cracks in them and
Yeah,
planes have known cracks in them and engineers are watching with these techniques to see if they get any bigger.
yeah,
And so you'll see a little crack and you'll measure it and be like, okay, is it getting too big? And on
yeah,
some aircraft, mostly military, they'll do what's called a stopgap to your point, which is they drill another hole in the aircraft at the end of the crack because the tip of a crack is the most stress that's going to see. And so if you drill a big circle, it alleviates the stress at the top of the crack. So
yes,
you can fix a plane by poking more holes in it, which is kind of
yeah.
cool.
Yeah, the book I really like talks about that, like mechanisms like that a little bit, which is really cool. Yeah, um, specific like energy release mechanisms through intentional weaknesses. Fascinating. There's probably some metaphor for life in there, but I'm too tired to come up with it. Um, well, that's rad. The did you do mostly the testing side of things, or did you were you well familiar with like analysis methods?
It was a bit more on the analysis side that my group was tasked with writing the procedure for it. So like a new part would come in and it would say like, how do you test this? And we would write a procedure and verify that the procedure would work with the techniques we used.
So you like know everything about fracture mechanics. Maybe I can just
Ah,
sign you up to teach a couple fracture mechanics lectures on in my class, so I don't have to do it
I'd need a big refresher on it.
because you've been doing other stuff for a while.
Yeah, yeah, it's been a while.
Yeah. So even like a pristine part, something that's not flown before, has some like initial defects, right?
Yeah, I mean, ideally none, but we live in an imperfect world. All our processes are gonna have some kind of defect, unless, I mean, there's some turbine wings are single crystal growths. So like if you think of a metal being a bunch of different lattices of metal crystal, they can grow a single crystal that has no breaks in it. But that's getting too into the weeds. It's just there's a lot of cool stuff,
No, I
and
want to be in the
it
weeds here.
infinitely opens up as you look into it.
But like you could go take a completely pristine wing and fly a nominal flight, maybe some gusts of wind, but you don't hit a bird or anything, and come back with some defects just through normal, yeah, just because did some flapping.
Oh
And
yeah,
then you
definitely.
grow and you grow and you grow. And eventually you have this very, yeah, okay. Just trying to calibrate my own mental model. Like, it's just
Definitely. Yeah,
like,
it's like if you take something perfect and you bend it enough time, it's something's going to happen inside it.
it's like breaking a paper clip.
Yeah.
Uh, the I'm trying to like, is there a specific point where like traditional stress analysis with some ultimate failure stress and a stress concentration factor becomes less of a driver compared to like a cycle counting critical crack length thing, like an energy based approach?
Certainly, as you get really complex parts with really weird shapes, those models break down pretty quickly, and you rely on a lot of practical test data
Yes, yeah, yeah.
for, yeah.
And you know pretty well the difference between like strength and toughness of different materials. That's one of the things
Hmm.
I'm trying to wrap my head around because it seems like a lot of materials you kind of get one or the other. Is that kind of the right
Right. Yeah. With the,
observation?
I've, I mean, now I'm going back into the old John, but that's, I fear I might say incorrect information, but I'm going to say it anyway.
I'll bleep you
So,
out.
yeah. Yeah, with the difference of metals being like super strong, and then also having a very like you can have a high strength point, but then you can also bend for much more. So like the example that comes to mind is titanium is incredibly strong. It takes so much to bend it, but it's gonna once you reach that critical point, it's gonna shatter, and it's gonna
Yeah,
shatter catastrophically.
yeah,
Other metals will bend super quickly and will deform non-elastically. They won't return to their shape, but it gives you so much more life out of it before it fails at
Yeah,
that critical juncture. And a lot of airplane designs and also like rocket designs have that in mind. It's a balance of the two.
yeah.
If you want something to last,
You're going to see a lot of cycles.
yeah. Hmm.
Okay, cool. Thanks for clarifying that. The toughness is like your ability to absorb large amounts of energy, which where the deflection plays a piece, and most like super
Hmm.
strong stuff. Um, the uh, it's the deflect. It's how much force you can take, but the deflection piece doesn't really matter.
Hmm.
So you're absorbing less energy, and so you actually can't store as much strain energy as a part that's more tough.
About right.
And then you can have specific like energy release mechanisms like these holes you're drilling in um, to reduce the
Relieve
drag
stress.
propagating.
Yeah,
Yes. Okay. Let's move on because you're a programmer now in programming school.
I am. I'm a computer man.
So when did that transition occur? And oh, I'm also like interested in like, did you like being in the R&D department? Because that sounds like an awesome department. And how did
Yeah,
R&D fit into like the rest of Boeing as a company?
R&D was a super cool place to be. It's like the main part I liked about it, and I think it's true of most engineering departments or jobs in general, but I was surrounded by some incredibly smart and driven individuals, and so much of engineering doesn't happen in a vacuum. It's all about the people you're around and the interactions and what you can bounce off each other. Like I was a new engineer, but if you surround yourself by these really wickedly brilliant people, I found myself coming up with better ideas just by
Yeah,
the
yeah, yeah.
sheer like knowledge base around me and encouraged to do so by these people. So that and R&D is like historically a department where I think those kind of people live.
Yeah.
They like to congregate.
Yeah. It's arguably one of the best parts of being an engineer
Mhm.
is the like the collaborative element and just like being around other engineers who think similarly and challenge you and like help mentor you.
Mhm. Yeah, and it's the best part of school too. Like that was how I like one of the reasons like school got so much more rewarding is the collaborative aspect of it. It's it's so important
Yeah.
to take your students, teach things you understand to your fellow students, and
Hmm.
get taught by your other students. I've left so many study groups knowing that even if I entered a study group being the most informed person about a class, I came out knowing so much more just by helping the people around me.
Cool.
And I think that's true in the workplace as well.
Yeah. Um, okay, so switching from that to a new discipline, that sounds like a
Hmm.
major pivot. What motivated you to do that? When did you do it? How did the opportunity emerge? Talk to me about that.
I like a lot of things in my life. It kind of happened unnaturally. Like I stumbled into it a bit.
Yeah.
I had this propensity to code a lot of the things in my job because I liked it. So I was doing a lot of data analysis with different Python packages and trying out like MATLAB was taught in school. So I was using that, whatever tools I kind of was familiar with as much as I could in my day-to-day life. And then one of the software engineers who was in our group retired unexpectedly.
Mm.
And he took a voluntary layoff. So we had a big period of overlap. And my boss came and was kind of like, "Hey, I saw you on IDE development environment once. Would
Yeah.
you like to be our new programmer?" And I said, "Hey, heck yeah!" And I spent like 4 months under this guy's tutelage before he retired
Yeah.
out of Boeing, which was really it was like a crash course in being a software engineer.
Yeah. Um, that's awesome. Whoa, a Cybertruck just drove by. Okay, you don't see that around our house too much, and it's snowing.
Ooh, how's it doing?
I don't know if it's sticking much, but it's coming down. So that's great. Stayed at Boeing, same team-ish, like you still got to work with the same people, but
Mhm.
you became the programmer, and in a 4-month period, a very experienced mentor trained you in the ways.
He did, and then he left, and he left a big hole of 30 plus years of software engineering experience in this specific team. And I was not equipped to fill that hole. And so I eventually left. That's when I made my transition to the other job. I
So
was,
Wait, so the 4 months was like not enough because he's got 30 years
Oh
of,
no.
but
Yeah, yeah.
during those 4 months, did he just like, was it just like 24/7 school or like, was it just kind of like, how did you guys structure that?
I basically woke up, went to the job, and sat in a chair behind him for 4 straight months.
Like
And then
shadowing?
eventually tried to sit in the chair and did a reverse shadow for
Wow.
the last like month or so, where I would be in the programmer's chair and he'd be looking over my shoulder,
Yeah,
telling me what I was doing wrong and right.
that's super unique. And this was still all in service of crack and ND
Yes, yeah. Writing
cracks.
bespoke programs for our group to then deploy to collect data for different NDE methods.
Sick. But it was too much. So how long did you go without him and in this role?
I lasted another 3 months or so, and I wasn't getting the help from management that I needed to fill this guy's shoes. I mean, he did a great job. He was such a
Yeah.
nice guy, and he was telling me and management that, this wasn't gonna be enough, but there was a hiring freeze. They said they couldn't do anything about it, and then eventually it was up to my own. And I don't know. Yeah, I started looking for other opportunities and got one in a role that was gonna mentor me in a much more structured and longer capacity.
Yeah. Staying in comp sci or programming,
Hmm.
staying in the same city, and uh, so that's great.
Yeah, it worked out. And the team, once I left, they eventually got, the funding they needed once they had no software engineers to hire up
It's funny how
a
that
team
happened.
of people to replace. Yeah,
What interview was harder, Blue Origin or Boeing?
definitely Blue Origin. Blue Origin, they had a bit more structured interview where I went through rounds with the team, then a coding interview, and then a hour-long PowerPoint presentation about projects that I had in my past that related to the new job role.
Yeah. Were there any projects you did at Clemson when you were an undergrad? I know you were on the rowing team.
Mhm.
Was there anything you did on like the engineering side?
Two class projects, and then we had a capstone senior design project. I was focused primarily on chemistry at that point, so
Yeah.
uh, relatable in a different sense, more.
Does Clemson have a like a apprenticeship semester thing?
Not really. I did a co-op and then a bunch of internships.
Yeah, that's what I meant. A
And
co-op is the word.
oh, okay, yeah, yeah.
So what was that? Who was that with?
I did that at Parker Hannifin. It's a
Yeah,
rubber seal
I remember that.
manufacturing plant.
Yeah. Did you like that? What was their culture like?
Uh, Culture was good. It was a very strict manufacturing environment. So there was a bit of a rigid culture in the sense that, like, I had a punch card that I needed to clock in within
Okay.
5 minutes before my shift start.
Yeah.
But as with all organizations, it's really about the people and your immediate
Yeah.
team, and then it's some really nice uh, mentors there. It was another R&D department within their rubber development, and they were really forgiving of mistakes, nurturing of talent, and it was a really good opportunity that actually parlayed me into my next opportunity. So they
Okay.
made rubber seals for a lot of applications, including aerospace. The part claim to fame that they had was, or infamy, they developed the seal that failed on the Challenger,
Wow.
which actually wasn't the seal's fault. It was another kind of fatigue issue.
Yeah.
But is those aerospace seals, I then got a job testing the leak rate of those seals at NASA in Cleveland for my next internship.
Okay.
Just like having that knowledge string going through.
Yeah. Super cool. I was gonna ask like how different experiences like fed into certain technical abilities at like later ones, and you answered that already. And you had some of the coding experience from your master's that ended up helping with first Boeing and then Blue. So then at Blue though it was not NDE, it was additive, or did you come in doing NDE at Blue? What was the domain
I
transfer?
came in doing straight additive, and one of the reasons I was hired is because of my diverse background. So having a material science degree with software engineering experience, working for a team that was developing machinery to build highly critical material sciencey products. So it was metal 3D printing.
Yeah.
And I, in my interview, was convincing them basically like, hey, you want someone writing software that's going to do a process for a material who knows materials. It helped me have conversations with engineers farther down the technology line to inform the software I'm writing.
Yeah.
There's no bad experience in that regard. You know,
Yeah.
everything builds on each other.
Yeah, that's really powerful. I see why they wanted you and why they hired you. Because I bet that helped them a ton. So when you started in that job, and you said they spent a lot of time on the front end training you in the software piece, or
Uh, I mean, it was a bit of trial by fire, but not really trial. There was, I had a mentor. It was like a two-person unit, another really senior engineer who's been programming for his entire life.
yeah.
And I was his little like mentee, and he like mentored me, brought me along, trained me as we worked on this very demanding project.
Hmm.
It's a really unique situation where again wasn't a formal training program, but ended up working out quite well.
Yeah. And do you feel like do you feel like those two periods with those two mentors at the two different companies were like some of the most rapid learning of your life, or were those like, yeah, what were those like?
Especially the second one, it was, you know, I got a lot of autonomy with a super experienced individual who sat right next to me, and
Hmm.
there was a bit of oversight, but then the project demanded a lot of attention from both of us individually. So it was a lot of self motivation to constantly not know something, try and figure it out, and then, you know, turn to my left and say, "Hey, I can't figure this out. These are the steps I've taken. Can you help me?"
Yeah.
Just a lot of a year, over 2 years of, "Can you help me? Can you help me? Can you help me?" And it felt like I was being annoying at first, but
Yeah.
uh, the patience level was high, and you know,
Yeah.
people
Thank
people
God for
like
those
being asked for
patient
help.
people. Yeah.
Yeah, I mean, thank God for it, but also I found in my career that people, you know, people are so generous with their time and uh, their capacity to help if you just ask.
Yeah. Um, that's great. Now I want to hear like some specifics about additive and about AI. Would you,
Yeah,
and maybe the intersection of the two.
yeah.
So you were working on metal 3D printed parts, so laser sintering
Mhm.
stuff with the powders. Um,
Laser powder bed fusion.
and what was Blue making with those?
All like all sorts of engine parts.
Stuff for the
So,
BE4 methane engine.
mhm. Yeah, I can't say specifically what, but
Yeah,
if you have a keen mind and you look it up and you see a picture of the engine, you can usually suss it
yeah,
out.
yeah,
But I will say for a lot of these earlier starts, additive allows for rapid iteration of your part design.
yeah,
Traditional manufacturing would be casting a part, so you pouring molten metal into a mold,
yeah,
and then you can do that a bunch of times and make thousands of engines for super cheap. But developing that mold and that process costs so much money and takes so much time. So you better have your process right.
yeah,
So you're going to make only that. Additive processing, it doesn't scale like casting does because you have to 3D print each one, and the time to print each one is not going to get faster unless you make small changes. But there is like a baseline speed that it's going to take as metal melts as it does, and you know you can't change that, and it cools especially at a particular rate.
Does that eventually bottleneck production if it's slower?
Absolutely.
It does.
Yes, so you are physically limited by the number of machines, and you're limited by the space and resources for
For the
those machines
entire
as
engine,
well.
like the entire engine production rate is
For
on the
sure.
speed
Yeah,
of laser printed parts.
especially if there's certain size parts. So as parts get bigger, they become infinitely harder to print. And then there's only a certain amount of printers in the world that can do certain parts. And so you're limited by a build envelope and then you may only have two of those machines. And if each engine needs one part from those machines, suddenly you can only produce two a month.
So you bought the printers from a third party, um,
Hmm.
and they're pretty hard to make on your own, I guess.
Yeah, they're incredibly difficult and technically challenging to make. And they
Why is
flew
that?
at a common, it's a high precision part. So I wrote calibration software for a lot of machines, some like, out of house and some custom. And you need to like to bring it all the way back to the fatigue life. The surface of the parts have to be so smooth. And if you have like ridges in it or imperfections, that creates an area for crack propagation, especially when they're being flexed and cycled on engines. So you have to have your lasers moving from a distance in error bars of 30 microns. So
How do you
you're
like isolate from just like general factory vibration and like does that stuff impact the build?
It does, and that's why they're designed in such a way to be isolated in that manner. So they're on these separated concrete bases, and the machines themselves have vibration dampers in them. And then you have compensations in your motors to watch for vibrations. And you can also take the general vibration of your factory out through calibration if there's like a baseline noise. Kind of where I was in the mix as far as writing that software.
That was a lot of your magnum opus in terms of your work output is the calibration of these massive laser 3D printers.
Yep. If a part came out and it looks pretty crappy, they would say, John, what the heck? What went wrong in this print?
Because you knew also the consequences of a bad print from the surface quality perspective too.
Mhm.
Was that something you handed off to someone like you guys take a print out and so you guys say this is a little funky. Who makes the call like we can fly this or not?
Well, there's always like, this whole pipeline of testing before it gets close to an engine. And a lot of that testing was my, prior career. There's
Yeah.
non-destructive testing that happens on almost every single manufactured
Yeah.
part that comes out of a printer. And they do like x-rays and ultrasonic testing. And I basically just moved like a step farther back in the pipeline, closer to the source material
But you could have
from
really
my
been
last job.
responsible for all of it.
Yeah, yeah. But,
Yeah.
time, resources, focuses. So my counterparts next in the line were all materials engineers working into E roles.
Okay. And who makes these machines?
There are a couple of major suppliers, a couple of in Europe and a lot of Chinese suppliers, but American rocket companies don't really want to buy a lot of Chinese products at the moment because of unfortunate political circumstances.
Yeah.
Um, I could look up a few if you want, but
No, it's no big deal. I was just curious.
yeah,
Do you believe in the technology? Like, do you think that it's a difference maker for like the bottom line in terms of rocket development?
do. It's, as I mentioned before, so important for development, being able to rapidly change the geometry of your part in a day. You can come to a 3D printer with a new model, and if you can design a support structure for it and a heat tolerance, you can print it. And
Yeah.
then you have a brand new geometry of the same part, rapid turnaround. And then on top of that, there's
Wait,
better
how
material properties. Well, it depends.
something you could hold in your
It's been
hand, how quick is that being made?
if you have a really good engineer who can design a support strategy within a day, then a part like that, this big,
Wait, a support
prints.
strategy? What do you mean? Like supports like on a
Ooh,
normal
sorry,
3D
yeah,
that like the overhang
getting
and
over
stuff?
my, yeah, yeah. So you have to every part you have to design supports because we can't print in space yet, or
An
so, and
engineer
on
an
most
engineer
modern
has to
printers.
manually do that. There's not like an algorithm to
There is, but there's small tweaks that these wizards of 3D printers make where they see the support strategy that gets automatically put in, and they go, "Ooh, that's not going to work because there's going to be too much heat build up here, which is going to cause the
yeah.
part to buckle."
The
There's
relativity
a lot
people
of
talk about
stress.
this a
Yeah,
little bit from the heat perspective. How you have to like account for thermal stresses on the like on the back end, and a lot of
yeah.
that's
They
on the
actually
software side.
print it out of shape,
Yeah.
assuming that once they pop it off the build plate, it's going to return to that shape with all the heat. like the
Yeah.
stresses are relieved,
Yeah.
which is
So you and
pretty wild,
relativity are
the math.
you and relativity
But
were kind of solving the same technical problems. I should really connect you with my buddy.
yeah, I think actually the head of the relativity additive program right now came from Blue
Okay.
or someone high up there. There's a big pipeline, all the aerospace companies are basically poaching off of each other.
That makes sense. Um, so you're a big believer in it, and do you think engines should like eventually make the switchover point? Okay, the design is finalized. We're 5 years down the road, like, and start casting them a part that you're not in the development phase.
It's yes and no. I'd say, and you see this in practice, especially at SpaceX and where Blue Origin is probably going to be heading, which is you're gonna want most of your rocket engine parts casted at some point.
Yeah.
It's just so much faster and infinitely cheaper. If you can stand to have them casted, most people do. But what is not always taken into account is you can make a 3D printed part so much lighter because you can achieve geometries that are just physically impossible to pour metal into the shapes.
Yeah.
And that makes them lighter, it makes them stronger, and it makes them more flexible and last longer. So, like all things, it's a huge balancing act.
Okay. So yeah, the on certain simpler parts without the crazy geometry, you want to cast something, but then there's high performance parts where you can do stuff on a printer that's not capable from a cast part. Okay.
For true.
Nifty.
Yeah,
Neat. Do you think like the tech is going to get a lot better over the next like 2 decades in terms of additive?
they do. And we're already seeing it with several companies producing one larger format 3D printers, being able to build bigger parts than we never thought was possible.
Yeah.
And also the speed is getting down there. Like I said, there is kind of a logarithmic decay where you're gonna hit a plateau at some point where the changes you make in the speed of your products are minuscule but still there. But it's we're still high up on that curve. It's gonna get faster and faster and faster.
Gotta love the old log deck.
Yeah, you're a math man.
Do you think most of the improvements are going to be on the hardware side or the software side or like just both?
Both. I mean, a lot of my job, a lot of improvements were implemented on the software side, but the strategies at which you speed up a process are all like a bit more, mathy and conceptual. Anyone, you don't have to be a software engineer to figure it out, but you did have to be a software engineer to tell the lasers to do the specific strategies. So in our situation, it's like multi laser systems. So you don't have just one laser working, you have four or a dozen lasers working and
And you're telling
at
me you
different
didn't have to do
times.
any math with all that?
No, it was riddled with math, just in really concentrated bursts. Like I do no math, I just program for weeks, and then suddenly I figure out what a Fourier transform is again from ages ago, or do different polynomials. It's just like it's back what we said before about learning to learn.
Yeah.
I didn't have to do math on my day to day, but I had to relearn how to do math
Yeah.
really quickly, or else I'd fall behind.
Yeah.
And then you can forget it again. You'll do it later.
Yeah. What was like the hardest problem you had to solve on that stuff that had you kind of most beating your head against the wall, if you can share? Or the one that took you the longest?
It's definitely on the calibration side, just because there are so many factors in play. So we would be calibrating a machine and, it's off, or a single laser is off and it's been working fine for a year. And then suddenly you're getting one laser that's erring outside of your control bounds by a significant margin. And you have to go through this like root cause analysis study and you have to do it fast because now the machine's out of production.
Yeah.
And
Oh yeah,
it's
because people are you're holding up the whole pipeline.
exactly now rocket engines aren't being built and now the engine's behind and
Wow.
it's goes all the way up the tree and people start getting angry back at you until they finally find you the cause of the problem. uh,
You don't want to be that guy.
don't want to be that guy, but it does help to have really nice managers who
Yes.
are really
Stay away from
okay with
John.
failure. Yeah, they shield you and they also say, hey, like I know you're gonna make mistakes, I know you're going to learn from it. Just have a plan when you make a mistake.
I
And
literally
that's
think
what,
that's so important. And I feel like every engineering manager and leader, yeah, needs to keep that in mind, just how much power they have to to fight for the people who are working for them and how important that is.
Mhm.
So like what were the different variables affecting the calibration? Like I feel like and I see engineering as like you have all these knobs to turn and they're going to affect the final
Yeah,
outcome and you're trying to find like the biggest knob. But sometimes it's like some
exactly.
smaller knob that's making it the calibration issues. But like talk to me about the different knobs you had to turn and like which ones really mattered a lot and which ones did not matter a ton.
To your points, the big knobs and little knobs. So you always start at the big knob,
Yeah.
which is you look at the motors controlling the laser and you say like, is there noise in the system, or have these gone bad? Like they, they're machines. It's metal. Something will fatigue eventually, uh, and it's going to break. And has that time come for your most critical components? And then as you get farther up the tree, you get to the smaller branches, the littler knobs, and that's stuff like, was this the chamber that houses our lasers? Did they get a little hotter than usual? Because at these small measurements, like 30 microns, even like a few degrees change can change the position of the laser just because all the components are thermally expanding and contracting. In this case, one of the hardest ones to track down, uh, our process got really hot because cooling failed to one of the galvos controlling the x-axis on our laser.
Wow.
So the diagnosis process was very it's like an investigation. You see it's off, you figure out how it's off, then you notice that it's more off in X directions through iterative testing. That points you at a specific axis on your motor.
Yeah.
And then you find that there's a blockage in your cooling channel. Blow out the blockage with compressed air, back to normal, but you have to verify. Seems straightforward, took forever to get there.
Yeah, that's so wild and true. Can we talk about AI? Are you
Yes, yeah.
so the vibe I get from the news and my experiments is like it can do a lot of software engineering pretty well. Or maybe that one of the main use cases they're looking at for developing it is like they do their benchmark testing on how well it can write code.
Mhm.
Are you using it? What have you tried? What is your experience like? And where do you think this ship is going? I think you're in a unique
I'm
position because you're doing technical software like it's very physics and material science and engineering heavy. A little more niche,
mhm.
I would say. But yeah, tell me what you've experienced.
I mean, I definitely use AI in my job and will continue to use AI job. It's just a changing, the landscape's change. It's a tool in the engineer toolbox now. And just to address the AI elephant in the room, it's not taking, I mean, it's going to take some jobs, but it's mainly just going to change jobs.
But
So
can you write code quicker now or better code?
yes,
Like how much better has it made you at your job?
made me quicker. I don't know if it writes better code than I can write. That's one of the main sticking points, is that it's a predictive model. AI is predicting, like these language models are predicting the next thing
Yeah.
it's going to write based off of your inputs. It's a prediction. It's not an exact science.
Hmm.
So things are wrong sometimes,
Yeah, right, right.
a lot of times, and they might even work and be wrong. And when you're working on critical infrastructure in like a space program or even something that was safety oriented, it has to be right. And what AI my role was is I can put down a lot of stuff that is quick and easy, but then you really have to have the knowledge base to go back over it and
Test it. Yeah.
verify that it's true. You cannot use AI and assume that it's right because it just won't be all the time. And when it's not right, it may count immensely.
Yeah. Wow. Well said. What tools did you find like were most helpful for you? Like which specific?
And yeah, I mean, there's the big guy chat GPT. It's super useful. A lot of companies have their own internal model
Yeah.
based off of it. So you'll have like, I don't know, like an Amazon GPT or a Blue GPT where they protect their data. or else it's just kind of going out there. And then there's other like, kind of co-pilot tools and smaller examples of it where they do basic functions in programming. There are a lot of things that you write constantly for each aspect of your programming. Like in classes, you write getters and setters quite a lot. Populate those right away. And that's not so much AI, but more just an AI assistant anticipating what you need,
Yeah.
uh, and then typing out answers. But yeah, there's those tools, and there's going to be infinitely more because we're in a kind of AI bubble right now, and it's here to stay for at least some capacity.
Yeah. So with you studying it in grad school, how do you think about like the role AI is going to play and what you choose to learn? What are you learning about? What are the courses you're signed up for in this grad school program?
I'm studying it for a lot of generalist courses, and it's mainly so I can, earn multi-years in my career. And I'm 31, and I still don't know what I want to be when I grow up. Like I have no idea. So
Yeah.
we'll kind of want to figure out what I like again, out of this industry. And so I've been taking a bit of a shotgun approach in this. Um, but
Well, thanks for helping with
it's
education here.
funding the system again.
Yeah. Um, what classes are you taking? Just generalist classes
Oh
you're saying?
yeah. So yeah, I'm taking like a general programming class, which is taught mainly in Java. I'll take an algorithms and data structures class, which if you're a software engineer, that's less important. Really important in job hunts, especially. That's like the questions that job seekers will ask during your interview. Uh, they'll create these puzzles out of data structures and algorithms and ask you to solve them. And other stuff like cybersecurity, which is a super important part of any software developer's career because it's not taught very often and people
Yeah.
don't code with security in mind. Yeah, so stuff like that.
Yeah. Well, we're about at the 1 hour mark here, so I need to wrap things up.
Oh
This
yeah,
has been really interesting. I'm excited to talk more with you about this, just personally, and I'm
yeah.
interested to hear more about your process of discovery, and what you come up with. But thanks so much for
Be sure
sharing.
to edit that down so I don't drone on as much and make me seem super like witty and cool and quick. You know,
They don't have an AI for that yet. You,
well, they'll just be have to be you.
all right, John, thanks so much. You have a fantastic evening in Glasgow, and we'll be in touch again soon. Thank you.
All right, thank you.